I'm on the air. All right, good evening, everyone. First of all, thanks for braving the heat wave here tonight to come visit with us. Hear a great talk about generative AI and Docker and I forget what the other thing is, but and also hello to everybody out there in TV land. I know some of us will get that reference. So sorry we're a little bit late. The train from New York was like 45 minutes late, so we literally just got here like 10 minutes ago. So our normal agenda, as you all know, if you've been here for a few months, we thank our sponsors, of course, first and foremost. Talk about what's new. I'll introduce Anna after her presentation. Then we'll do our usual, hey, what's coming up type of thing, and go from there. So of course, Payara. They are gold sponsors. They're the makers of the Payara platform, which includes Payara Server, Payara Micro. There is a Payara Cloud offering, and then coming soon to a laptop near you is Payara Cube, Q-U-B-E. You'll hear more about that. And then Azul, they make the downstream distribution of their OpenJDK called Zulu. And they have integrated the coordinated restore at checkpoint, otherwise known as crack. Write your own jokes there. We partner with DevNexus, and of course this is run by the Atlanta Java user group. I'm telling you, I want to do something like this at some point down the road, but those guys, they put a tremendous amount of effort into putting together that conference every year. Usually it's in the springtime. This year was in early March. So, and then our per meeting sponsors, we have JetBrains that provides the licenses to IntelliJ IDEA, Eclipse Foundation and Jakarta EE, and then Romanelli's, where the pizza is from tonight. And we also recently made a deal with Firehouse to provide us discounts on pizzas as well. All right, memberships, as you know about the Jakarta EE ambassadors. We're also guest members of the Microprofile Working Group and the Jakarta EE Working Group, and also the Virtual Jug. All right, Payara has their podcasts. They've been getting more into working with Java user groups for the past 6-7 months. We had a podcast with them in January. Barry and I participated in that, and that was a lot of fun. And then since then, they've interviewed folks from the Torino Java group in Italy, Chicago and Seattle, and then the one in Germany, the Jug Oberpfalz. So. Well, I said this last month, but I don't think it got recorded because there was an audio issue, so I left it in there. So of course, Java just turned 30 a month ago yesterday. And this is going to run out soon, a LinkedIn Learning course by Frank Greco. So if you're interested in that, Frank says it takes 60 to 90 minutes to complete. And I left this up here too because there's a mentorship program that the New York Java SIG put together. The deadline to register was last week, or actually 2 weeks, no, last week. So, but again, this is something new that the New York Java SIG is doing. As you may know, we're involved in Java in education. Barry has gone, and you're a mentor?
Yeah.
Nice. Oh, for this?
Yeah.
Oh, awesome. That's news. Yeah, okay. Did not know that.
I didn't know it until today.
Oh, you were voluntold, okay. And then Microprofile 7.1 came out last week. I'm going to reserve discussion with this afterwards about the Microprofile Working Group dissolving and moving the specifications to the Jakarta EE Working Group. There's a lot of moving parts to this, so again, if you're interested in more, we can talk to you about it later. Nothing's been defined yet, but there's a lot into that. I'm not going to get into this. I mentioned JDK 25 and ramp down phase 1. Phase 2 will be next month, middle of next month. And then September 16th will be the GA release of JDK 25. Jakarta EE 11, you know that the core profile was released, then the web profile, and the Maven artifacts are already there for the platform, but the formal release will be later this week. So And then Jakarta EE12, as you know, work has gone underway. We are part of the Jakarta EE Future Directions Interest Group. So we meet every other week for that. So there's new specifications, a whole bunch that are being updated. So there's a lot going on there. They are targeting July of next year for a formal release. And you're probably saying, well, Mike, we just had 11 just released, right? So if you remember, 11 was supposed to be released this time last year, but they made the decision to upgrade the technology compatibility kit, otherwise known as a TCK, and this will help make more efficient releases down the road. All right, so with that, finally enough for me talking, we have Anna Chernyshova. Did I say that right? Oh, very good. And her bio is here in front of me. So Anna is a solutions engineer at Docker focused on developer productivity, containerization, shift-left testing, and test containers. She is also an open source contributor and a lover of Java and generative AI. You're going to go into shift left because I've heard this term being thrown around. So,
yeah,
cool. I look forward to learning that. So, without further ado, please welcome Anna. You have a microphone there, yeah? Okay.
okay. Hope it's good. Okay. First slide. Today we will talk about testing of GenAI with test containers and Docker. Few words about me. I work at Docker, and previously I worked at the smaller startup named Jar. I run customer success and some engineering there. We were acquired by Docker, and the startup was focused on test containers and test containers cloud. This is part of the topic that we will cover today. Just before we continue there, who is familiar with test containers? Test containers. Okay. Okay, we will jump there. What we will be talking today about? A bit about generative AI in general in the software development. What is the general patterns right now that we see? How to test the deterministic part of these applications, how to test non-deterministic part, and I will share the resources that we talked through during this talk. First, GenAI landscape. I am personally a bit overwhelmed with everything that's going on there. Every time you open LinkedIn, there is something new. Somebody is doing a post about, I learned this new GenAI thing, there is a new framework, there is another thing, and kind of a lot of going on. This is probably the general, very, very high level diagram of what we have right now. Example is, let's say the chatbot. We have a user who submits some prompts. Then we have an application that will process this prompt. If you have an LLM framework like LangChain, Spring AI, LangGraph, Amazon Bedrock, a bunch of things there as well. Then eventually this framework will talk to the model. That can be something that OpenAI provides, or Anthropic, or some models from Google, open source models from Hugging Face. There are millions of these models. Then we have the RAG part. This is where the knowledge will be stored for the model to use it while generating the answers. And we have the tools calling that can interact with another tools, like search the internet, provide the knowledge to the model, and the model will process it and provide the answer using this knowledge from the tools. If we think again a bit from the high-level perspective, this part can be pretty similar to the cloud-based applications, but instead of the LLM, there will be AWS, there will be a Google Cloud, there will be some cloud resources, there will be a framework that can talk to these resources, and again, our application can talk to additional third-party APIs and process things with the cloud. So kind of the architecture is pretty similar, but still there is this non-deterministic part of the models that kind of makes the testing of the whole system challenging. The deterministic part is RAG. It's like pretty well known. There is a database, and we can test databases. Tools, again, this is just an API calls. We know generally how to test API calls, but this non-deterministic part that can reply with different things based on, just situation, it affects the application behavior. Coming back to the testing of non-deterministic part, this is where test containers helps. For example, we know how to test like cloud resources with local stack. We know how to test Spring Boot applications with test containers. We will cover it on the next slide. We know how to test databases. We can set up the Docker container, or we can go with the test containers. Test containers is an open source library that helps you to speed up integration tests and kind of shift left the integration testing. With plain Docker containers, you can spin up the thing, you can spin up the database, for example, interact with it, use it for application testing, and then turn it down. The same with Docker Compose. You can define multiple services that you want to use with your application. You can spin Docker Compose up, run tests, then you need to spin Docker Compose down. Test containers allows you to do the same, but with the automated way through your code base. This is example of how you can spin up the database, like the PG vector database that will store the vectors in the RAG. You can do it through the test code on demand. It will be in ephemeral resources that will spin up the container with PG vector when you do test run. When tests are complete, this container will be automatically destroyed. So kind of it provides the programmatic API to manage Docker container environments for your integration tests. You don't need to wait for containers to be available on some integration environment. You can spin it up locally, run tests, and have the results on your local machine without kind of doing DPR and waiting for the pipeline to run. Let me pause here if there are any questions about test containers at this point. Yes.
PG stands for Postgres. The PG and PG vector, does that stand for Postgres?
Yeah. This is the vector database that is compatible with the Postgres database.
Does it actually spin up the Docker container behind it?
Yeah.
And can you explain that shift left that you keep saying?
Okay. You can spin up, let's take an example of the database. You want to test things that you can create products and put them into database. You're developing this API. In order to test this with the real database, the common approaches are going with the mocks or with the H2 database, substitute for the Postgre, run this test, but when the code reaches the production, the real Postgre may behave differently than H2 and then the mocks, so it's kind of not real testing. Can be in some cases, like there are exceptions. Most popular approach is to run integration tests on integration environments or QA environments when you have the shared database and multiple teams are using this database and run tests against the same database, create tables, update products. But when multiple teams has access to the same thing, it can be fragile and can be broken. So you run the tests, you see that data were overridden. Test failed, not because the code is not working properly, but because the data is not good. And you had to wait before the code reaches this integration phase in order to get the feedback about the application, how it behaves. Shift left in testing is helping you to move the integration test closer to the developer inner loop. So with test containers, you can spin up the database on your local machine before committing the code changes, run the integration tests, and be sure that the application behaves properly with the real database.
So shift left kind of closer to the beginning of the application development process, essentially. Okay.
Yes, yes.
Got it.
Yes.
I have a question. So, like local Docker development, you can cache containers and such, right? But with this test containers, you say you destroy everything, like you spin it up, destroy it. Does it, like, for speed purposes in testing, how does that work in the background? Is it just background, just like normal Docker, just caching the images?
There is a resource reaper container named Ryuk that automatically spins up when you define test containers and dependencies. It's tied to the test framework implementation. So if you use JUnit, for example, you like to, I don't know, this Gradle test. It will initiate the test task. Test containers will understand that there is a test task initiated, spin up the containers. Ryuk container will spin up. When test containers, base containers like Postgre, for example, like when tests are done, Ryuk will understand that there is an event of end of the test cycle. It will understand that, okay, during this test cycle, I spin up the Postgre database, and it will automatically do the kill command, and it will turn down. Yeah.
I'm a novice, but my question is, and how the test containers are already pre-formatted together, so you just go in and put the software in and run the test, or is that something you buy from your organization?
It's an open source.
Open source means it's open to everyone, or just
Yes.
and just download it and run it and.
Yeah, it's a
Library, like just the Java library. It supports multiple languages, more than 10 languages right now. You just add it as dependency as any other tool and can use in your Java code. I will show in the demo later as well.
Can you spin up multiple containers, like say, not just Postgres, but maybe Kafka or something else?
Yes.
Just a few lines of code. With Kafka, it will be a similar setup, but instead of PostgreSQL container, you will have Kafka container, provide the image of what version of Kafka you want to spin up, and it will spin up.
And you spin up both Kafka and Postgres, or you need to define like a list of containers or something like that?
Spin up as many containers as you want. Before each test, before whole test suites, before test suite in specific test class. So you kind of programmatically manage what containers do you need for specific test execution.
And when you do start, is it blocking that method start, or is it going to block until the container starts?
This is like PostgreSQL container here is a module implementation, abstraction around the technology. We have implemented the waiters inside of this implementation, so it will wait until the specific log available and port available for Postgre. And when container is ready, like you will be able to interact with this. The start command, it will just interpretate the start into kind of underlying Docker API that will trigger container, run, port, host, etc., whatever is needed for specific tool.
You mentioned it has like 10 different software. At the same time, they don't complement each other. Because you might want some may have to get with packages that they don't have certain views, so they will complement each other.
They will not conflict these containers because every time you spin up container using test containers, it will use the random port. That is, yeah. Yeah. yes. You don't need to hard code the port, but it will use what is available on your host and just spin the container on that port. Every time it will be a new random port. Okay, let's move next then. We touched a bit the modules concept. The basic concept of test containers, like the basic building block, is generic container, where you can provide everything that can be run as container. You just need to provide an image and how to start it. If there are some specific ports that you need to proxy, environment variables, etc. The modules concept, it helps to speed up things even more. There is a bunch of modules, more than 100 already. That is just a high-level abstraction around some technology, like Postgre example, just an abstraction around Postgre. I can show later in the code how it looks like. It just hides the implementation of the container start, like the wait strategies, that we need to wait for specific log to be available to say that container is ready for tests to interact with this.
Integration with Kubernetes?
We have K3S module, yes. Okay, I can show after finish with slides. I don't have much slides. After finish with the slides, I can show the modules as well. So for the GenAI testing, test containers also provide set of modules, like for the vector databases, to store data for the RAG, where you can store the information that model will use after and kind of interact with the application.
We're getting a music concert.
Yeah.
Okay, let's move to non-deterministic part, and we'll go to the code where I can explain more about test containers and the testing concepts. So for the deterministic parts, we can use test containers, we can use just Docker, we can use Docker Compose to spin up databases and the things that provide the deterministic responses in the GenAI application development. But what to do with the models that are non-deterministic? In the demo example, I will use just a very simple Spring Boot application. This is an agent that provides answer to the question. I have default question that I ask this agent. It can be changed. But again, I'm just curious who won the F1 2024 Great Britain Grand Prix. No data yet for 2025, but yeah, for 2024, I am wondering who won this race. To build this application, I will be using LangChain4j. Who is familiar with LangChain4j? Okay. Okay. I will explain. And the model will be Gemma string. There can be any other model. We can change the model and see how application will behave as well. Also for the RAG part, I was just experimenting. LangChain4j provided better capabilities earlier than Spring AI. So it was just kind of I kickstarted this project when LangChain4j provided already features that are needed. Yeah, and the RAG part, there will be pgvector database that we will use test containers to spin up, and the content retrieval model, like this one, by some model. Again, it can be changed, just the demo application. So LangChain. This is the framework that helps you interact with the large language models. Again, you can write these things by yourself. You can call the APIs of the model, like let's say OpenAI. You can call the API, you can process the calls. You can do the same with Anthropic models, just use their API, implement how API should work. But if we think about the analogy with the cloud-based application development, again, you can implement how to interact with AWS, you can implement how to interact with Google Cloud, but most likely you will be using some framework that would help to interact with them, like for different AWS services, or like for AWS CLI. There are frameworks that have this high-level implementation that you can reuse. The same LangChain is doing for interaction with the models. It just provides the high-level things that you can use to interact with the model, to call the model, to interact with like RAG, everything that is needed. So you can easily switch between the models because, again, OpenAI, Anthropic models that are open sourced on the Hugging Face, they would have the differences in the API calls, and you will need to implement the call every time differently for each specific model. LangChain already provides this, so you can just select what API you want to use and use it. It also provides capability to calculate embeddings and work with embeddings. This comes into place when we work with the RAG and we use vector databases to populate data in the vector data stores. Yeah, and again, it can talk to vector databases, so kind of framework to implement GenAI-based application development. What we will be using again is the concept of embeddings. Who is familiar with the embeddings? Okay, good. Yeah, so for this, we will need an embedding model. It just converts the text into numeric vectors. And then we can use these vectors to search data or like to compare these vectors to understand how data is similar based on the semantic meaning. To compare data, we can use Cassin similarity that would kind of answer how similar these vectors are, again, in terms of the semantic meaning. If they are the same, like there will be answer like 1, Cassin similarity will be 1. If like they are unrelated, Cassin similarity will be close to 0, and if they are opposite, it will be -1. This is kind of just a general example of the embedding. You need to create the embedding model. This is the specific model that can translate data into vectors, like the semantic meaning. Then it can put 2 embeddings to the store, like about the cat, small animal, tiger. They are similar by the semantic meaning, but they are not the same. So if we calculate the Cassin similarity between these 2 statements, it will be 0.5. So they are kind of not that related. There is a cat and tiger, and they are close to each other, but not. And next thing is RAG. This is how we put data to the database, to the LLM, so it can remember it and use it when answering the questions. So again, here we ask the question, then we do semantic search, do the content retrieval, and generate the response from the LLM. For this, we will need, again, the embedding model and embedding store that can translate the meaning of the sentence, like of the question in like this example, put into store. And when we ask a question that is related, the model will understand that we have this data in the store, will use it and use it to answer the question. Hope this was clear. Any questions at this point?
Just want to say I like the math aspect.
Thank you. I'm not that good at math. I don't know how it works in the very detailed implementation, but just, yeah, the general concept is pretty interesting. Okay, let's move next. How to run model. There are different ways. You can use the vendor. You can use OpenAI or Anthropic, Google, who is present right now on the market, to use their model, or you can use model that is open sourced and run it either locally or on your infrastructure. Popular way how to run models locally is Ollama. But we released the Docker model runner recently that is actually doing pretty the same things, but it's tied to the container runtime and kind of just goes with the same stack. Ollama is a separate tool that you need to install, that you need to know how to use. Model runner just goes integrated with the Docker desktop, and it actually should be already available in the community edition, so it's available for everyone, again, free and open source. What it helps to do, it helps to run models. You can run model from the Hugging Face, the open source model, just having the Docker desktop. You can put model as an OCI artifact to the Docker Hub. So Docker Hub now starts serving as a source for where you can find the models. It will use the GPU resources that are available on the machine to run the model and to speed things up. Yeah, and again, reduce the number of tools that is needed to start with GenAI development.
I have a question.
Yes.
My understanding is these models are very, very large pieces of software running lots, very, very, very CPU or GPU intensive. What kind of hardware do you need in order to run a model locally?
I will be running on my laptop. Gemma 3. MacBooks goes with the GPU, so it will use the GPU resources. And there are like different models. Gemma 3 is about 2 gigabytes, if I remember correctly. We can take a look. So it kind of can run locally with the GPU resources. The key point is having the GPU resources because model rely on them to process things.
So I really want to run it locally. Why not just use the OpenAI model that's running on OpenAI?
Yeah, you can. It depends on the application development.
I guess what's the advantage of running it locally?
There are some calculations going around what will be more cost effective. Go with the vendor like OpenAI because you need to pay for the tokens. If this is the application that requires a lot of communication with the user and you use their model, it will be a very big bill at the end of the month. From the other hand, if there is the internally developed model that is maybe more trained for the resources that is using that application should use, it can provide maybe more realistic answers. Again, depends on the case, but it will require the hardware. So it depends on what application is doing. for very kind of applications that require a lot of tokens, like a big bunch of texts or another resources to process for the model. For these cases, maybe local models would work better. Like, depends on the business model, I would say.
Is there any plans to add NPU?
To add what?
NPU, your processor unit. Because right now there are a lot of Copilot plus C, which additional NPU not use it at all.
I haven't heard about these use cases, but maybe.
Copilot plus C certification. A lot of those laptops with NPU right now.
There are a lot of things going on in this space. Okay, let's move next. In the application, I will be asking like 2 questions. There will be like a straight answer that I would ask my model to, and the rugged answer. The straight answer will not use the rug. It will use just the knowledge that the model has. And the rugged answer will contain the rug, like the file that I upload to the embedding store. So model can use this information when generating answers. So how to test it? Let's go actually to the application and sort things out. Okay. Is the font fine? Okay. So this is the application. This is the chat model implementation using LangChain. Again, Docker Model Runner provides open API compatible API. So we can use Open API Chat Model Builder and run it with the model that is running locally with the Docker desktop. This is how you can kind of implement it with the LangChain. Just provide the base URL for the model, model name, API key will be not needed here, and I will log requests. Let's open Docker desktop. And I have this feature of models here. These are the models that I downloaded. This is Gemma 3. Yeah, it's 2 and 3 gigabytes. We can change them and try to see what the small model will answer, but usually they are not that smart, and they even can't work with tools properly. Like with the tool calling, when model need to understand that kind of it should call another tool to get the data. Yes.
How big a database is and the data is to determine what would be appropriate for that one, correct?
Yeah, so like the size of model, it depends of like, yeah, how trained is it. If it's more trained, it will be bigger. If it's like very small and not trained, good, it will be small. These models I'm pulling also from the hub. Let me open the Google Chrome here. if I go to explore, there will be AI models. And you can see what models are available here. There is also like the DeepSeek, GEMS 3, Llama. This will be bigger, I think, 3.3. We can see there will be a model size somewhere here. Yeah, it's pretty big one. So you kind of, the workflow is the same, like with containers. You do Docker pull image. Here you do Docker model runner, run model. It will pull the model automatically and add it to your local storage. Again, here I can kind of run the model. I can interact with this model using the prompt window here. Okay, with HDMI, it's not opening properly. So can kind of go back and just use it on demand. In the application, it is just pulled, but when the application will trigger the interaction with the model, it will use the API to communicate to this model and kind of can ask the questions that we will ask in the application.
Which port is the model run on?
Basically just this. And so basically this is just a tab in Docker desktop. Then you can go, for example, to the hub. I think we will have it here. Yes, you do Docker model pull, execute these commands, and it will be executed using the Docker model runner that is integrated with the Docker desktop right now. And to interact with this model, you would need the URL that looks like this.
The port is 12434. Is it like a common port, or is it something that's somewhere in the settings?
In the settings. It is somewhere in the general, I think. Find it. No. Okay, it's somewhere, yeah. You just define it in the settings. I don't see it here for me. Yeah, maybe we just put it in another place with this release. Anyway, there is like kind of just the getting started documentation where you like particularly the requirement is to have the Docker desktop. Then you can go to the hub, pull the model, and in the documentation there will be the specific path where you need to enable this port in the Docker desktop to be available to interact with the model. Yes, there is an MCP here. Yeah, that's a toolkit that aggregates different MCPs that are containerized. So you can enable them through one place and configure again through one place. For example, like, oh, okay, it's not here anymore. But when you define the connection to some services that require authorization, you can do it again through the Docker desktop. All right, let's move back here. So we have this chat model. We have the content retriever. It will go to the resources, knowledge, and we'll use this file as a knowledge base about the races of Formula One during 2024. Who won? What type of race? Make it smaller. It will put it into the embedding store. Embedding model, it will be using, again, the model that I pre-pulled in Docker Desktop. That is the embedding one. This one. This is the specific type of databases that can convert data, like sentences, into the vectors. And for storage, we are using test containers with this PG vector database. If we go to the Postgre container implementation, that kind of we touched base at the beginning, you will see that it contains some implementation, like how to start, default database, username, password, environment variables, this very practical method of get JDBC URL. It will just format, so you can kind of implement it by your own or use the abstraction to get data from there. And it extends JDBC database container that extends generic container, and this generic container is the basic building block of the test containers that you can use to spin up everything that you want.
So, quick question on that. You had a JDBC database container.
Mm-hmm.
Is there something synonymous for NoSQL databases?
Yes.
I saw MongoDB in there was supported.
Yeah, since we are here, let's go testcontainers.com. We have modules, and this is the full list of modules that we support right now. So kind of more than 100. We can filter it by Java. For Java, we have the most selection. The test containers originally was born in Java, and then appeared in other languages, like just the similar concept, the same implementation. But the first implementation of this approach was in Java.
Awesome.
Yeah, and you can filter here again, like SQL, NoSQL, bunch of them. All right. So this was the base implementation, and there is the get answer agent that will provide this straight answer. Here it is. It will just call the AI service with the chat model, where we can provide the model name and base URL. Base URL is here. It will be talking to the model running locally, and the model name is this one. We can change it to another and see how it will reply as well. Let's go to the tests. The first approach, how we can test that the application will provide the proper answer, is very simple, very straightforward. It will be applicable for, again, very simple use cases where you do not expect the very long answer from the model. You can just use the contains and see that the keyword that you were expecting it is present in the response from the model. Let's run these tests and see how application will behave. So here we use the get answer agent, ask the question, who won the Great Britain Grand Prix, get the straight answer, get the direct answer. For direct answer, if I'm fast enough, yeah, you see there is test containers Ryuk. and there is test containers PG vector that were initiated to run this test. The test is complete, and they will be destroyed somewhere soon. Okay, no containers. This is the workflow of the test containers based testing. You just define what you want to start, and it will automatically spin up and turn down containers. All right, so only the first test failed, where we were expecting the straight answer. Okay, the model said Max Verstappen won based on some data that that model had at the point where it was trained. But because the second part with direct answer was using the data, like the file that we uploaded to the vector database, it had access to the more actual data that we were expecting this model to have. And the test passed because it really contained like Lewis Hamilton. We can go to the logs and see. Yeah, this was the answer from the rugged model. Lewis Hamilton won the Great Britain Grand Prix, and some additional information that it had from the rugged storage.
Another question.
Yes.
So how does, I noticed it took 30 seconds to run II's very simple tests. So comparing the strings. So let's say you have 5,000 of these tests. How is that going to scale? Like, will it take 3 hours to run?
If tests will reuse the resources, I assume that they would. Like the most time that is allocated here is to kind of spin up the resources and like interact with them. It would again depend on the resources that are available for the model. If the model is not having enough resources and is not replying not with the proper speed, then yes, these tests that are model related, they might take a long time. But I would not say probably that it will be kind of the exponential. Yeah.
Question I'm going to ask. Would it be based on the resource force hardware and CPU?
Yes. A GPU mostly. Yeah. Yeah.
So I guess my next question would be, what would be the minimum? If I may have older laptop, would it be a function of why the availability to use these resources? What would be the minimum? That's the question. For an operating system or even CPU for its.
That's probably experimental. Depends on the model. Here I'm using Gemma 3. It's not that big model. If I will be running Llama model, the resources of this laptop will be not enough to run a lot of tests. Like maybe it will handle couple of them, but not the big set of them. Mm-hmm. 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 Yeah. I would say that for 5,000 tests, like the laptop will be not enough. And this is kind of another challenge of testing the models. We will talk about kind of one more approach a bit later. But yeah, there are a lot of challenges with this. And to have 5,000 tests for the model, it's very, very good coverage.
Well,
yeah.
when you write computer unit, let's say you're, so let's say it's ran
Mm-hmm.
So I don't think you would start the model once and then make 500 queries, right? And I don't know how long that would take. So I assume that this 30 seconds, most of it was spent spinning up things and then
Yeah.
writing it down. So maybe it does scale well to like asking 500 queries, because you would not bring the model down, right?
But still, model will use resources to process the question, and it uses resources every time you ask the question. Yeah. Yes.
We have what I don't know if it's a question or a comment from Dimitri.
Mm-hmm.
This is out on YouTube.
Okay.
It says, RAG is a great technology. Suppose I need to generate YAML according to a certain specification. I use RAG to store the description of that specification and examples. Then he continues and says, but locally I run it on Quarkus and Podman.
Mm-hmm.
So I don't know if you want to speak to that for a second or.
Yeah. That's a good comment. Actually.
I don't think it was necessarily a question.
Yeah.
I wanted to use it anyway.
I use here like the JSON format to populate the data, and like usually, yeah, you need to pre-process a bit the data to put it properly into the RAG storage. So yes, it has like the metadata here, content. Yeah, it's basically the main thing here for the population.
So you're using JSON format here as part of your RAG.
Yes.
Right. So
for as a data storage for the RAG. Yes.
Data storage for the RAG. So I understand RAG is. I mean, I'm beginning to wrap my mind around a lot of this, so there's still a lot of questions I have. But so I guess the RAG is the part that you have, almost like having a built-in search to have some responses, right?
Mm-hmm.
That's where the data is stored in your any kind of RAG, and I guess the
Mm-hmm.
format.
Yeah, like kind of, yes. It's like the knowledge base for the database, like additional data that it can use in order to answer the questions that were asked. When the model is trained, it has access to the limited data to the time when the model was trained. It doesn't know what happened after. So this Gemma 3 didn't have like the data about the Formula 1 races when it was trained. So it just imagined the things based on the data that she knows, that Max Verstappen is a really good F1 racer. But when we provide the additional context, like the additional knowledge for the model, it will use it. Like again, if we put it into the RAG and say the model to use this information when answering the questions.
Very common when you want to feed the model some proprietary data, right? For instance, you have some kind of a FAQ for your own company or something like that that you want to run, and then you could use that data like and feed it into the model and have it answer the question specific to your business, which obviously won't be available on the internet anyway.
Yeah, there are a lot of products that are built around it, and there are like third-party services that also provide these capabilities. You can like use them, say that we need to have this data in our models, and they will be
MCP is
kind
getting
of
more popular than RAG these days. I don't know.
Yeah.
Because you can sort of like implement the MCP protocol and have a model pull the data automatically from your server or something versus having to feed it via RAG or something.
Yeah, the RAG probably can be cheaper and faster because MCP, they use the tools calling, and this is like another chain that should be initiated by the model, and it usually takes time again. The RAG, you just pre-populate it, it's one-time exercise and the model can use it, but for tools calling with the MCP, it will be just additional step to do. But if the model needs the real-time data, like if we ask the model what time is it now in medicine, it will provide some random things. But it can use tools to interact with the like time provider APIs and provide us with the proper time based on that response.
sense is the selling point of doing this in Docker is it's way faster than running it on an operating system like Windows or Mac or even on some server somewhere, because you don't have all the overhead associated with those operating systems. So that's a key selling point.
Mm-hmm.
Right?
Yeah, it comes with one tool. You can go again like with Llama. That is very popular way of how to run models locally. If this is like the model that you are developing or the company that you're working at is developing. But this is additional tool. Docker just unifies everything together in one piece of developer tool that you just download and have everything that you need, like containers, models, MCP, toolkit, different things for productivity.
Question. There's too many tools. With open source have all the tools, it would be many application tools. Various tools, AI, those would be a great use. Great.
For the open source tools, I didn't get the question.
I guess I mentioned tools.
Okay.
A repository of resources, two various tools can be used in AI, or is that not yet there, or is that within the open source?
Tools, did you mean like the tool calling that I said?
Right, various tools you may utilize in one
That's mostly MCP servers. They are again available on the Docker Hub. You can use MCP servers that has the tools implementation. It's like basically the API that every server implements. And the model can use this tool to perform some actions. Yeah, MCP servers, they are on the Docker Hub. There is also a lot of them on the GitHub. Usually you need to have, like, they are mostly developed with the Node or Python, and you need to have the specific version of Node or Python or like Go to start the MCP server locally. Or you can go with the containerization for this approach as well. Just pick it in the container, start the container, and it will run like, everywhere. Go, that's probably the most popular stack for the MCP servers right now.
So you had a slide that said kind of like example one, testing exact.
Yes.
So you must have an example two.
Yes.
Because this is not a great use case. It's not a realistic use case, right?
Yes. There is an example two and even more. Let's go like this. Okay, it will be just slide and we will go to the code. So we can use the Cassin similarity that we touched a bit earlier, where we can compare the vectors. And this approach can be used again to test some scenarios. Here it is. Let me do it a bit bigger. All right, so here is the same question. We can create a reference response that we can then put into the embedding store using the embedding model, and then compare this like two vectors between each other. This is the reference that Lewis Hamilton won. Then in the gate straight answer, we get the answer, put it into the embedding, so kind of convert it to the vector. Then we can use Cassin similarity to identify the difference between these two vectors, the reference one and the current response. With this number of the Cassin similarity, we can play a bit. Again, this would be something to define based on the like general tests and the model behavior. I just put here 0.9. So I expect that the vectors will be very, very close to each other, almost similar. The same for the rugged answer. Get rugged answer, put it into the embedding, and run the Cassin similarity between these two vectors.
That's a good way to do it, because you can't really expect the answers to be completely equal, but
yeah,
you expect them to be similar rather than equal, right?
Yeah.
But you're relying on this vector that you have probably no idea how it's being created. So again, if you're running days worth of tests, what does 0.9 mean? Quality
90%?
Yeah, 90%.
It means that these vectors, which are based on the LLM and other things, they're very abstract, right? It's not, I mean, that they're similar or dissimilar. Show your example, please.
Yeah, so let's go here to the logs. The vectors, so here again, like you see that the test with the straight answer failed, the test with rugged answer, it passed. The vectors and like storing the embedding is more or less predictable, because we kind of define the vector based on the semantic meaning of the sentence. Again, yes, like model is involved to generate this vector, but they are pretty reliable and used in the RAG as well. The embedding model converts the RAG file into the vectors, and then model can interact with them. So this is kind of just the conversion piece. Here in this example, again, the straight answer was the Max Verstappen one, and the similarity was 0.7, actually 7.9, almost 80%. So the Cassin similarity tells us how similar these vectors are. Are they pointing like in the same direction? Are they pointing in the different direction? So here they are almost pointing into the same direction, like by 80%, but still not the same.
Has to do with the cosine.
Yeah.
It's actually the angle.
Yeah.
So different.
Does differential. What? Does differential or something?
Really close, it's like this.
Yeah, they are like orthogonal or.
I think it's between 0 and 90.
No, so if I make a statement,
Yeah.
like raining outside, and then somebody says, I love soccer, are those completely opposite?
Yeah, they will be completely opposite.
So if he says, oh, if I like playing soccer in the rain, they might be closer.
If this is in one sentence, then yes.
So I mean, it's a very, very large dimensional space.
Yes.
And each dimension represents a different property of whatever it is that we're talking about. One dimension is going to represent weather, and the other dimension is going to represent the outdoors, and another is going to represent rain, and another is going to represent humidity, and so on. And when we get two statements that are close to one another,
Yeah, I think for me it's because I work on trading systems where you can't, after I run the test, I can't say to my boss, well, yeah, it's 90% correct. It is in production. So I don't deal in a universe that has soft answers, but it's very interesting.
Yeah, this is again like the exact challenge with testing the models, because they reply every time the different thing, and we can't predict it. It's like not deterministic thing. So we just try to make it as deterministic as possible. It will be not that fully deterministic. At least right now there are kind of, I don't know about approaches to make it fully deterministic. All right, yeah, and with this second example, similarity was 0.93. So they were kind of very similar, this answer and the reference. The reference was this one, yeah, that the Lewis Hamilton wanted. If we make it like smaller, that just Lewis Hamilton won the Great Britain Grand Prix without identifying the date, probably the similarity will be bigger. But again, this is kind of one of the approaches how to make things more deterministic. But there is another that is kind of the most used right now. Let me do the slideshow again. The most popular approach that we are seeing right now is using another evaluator to test the model. So it will be kind of LLM as a judge that will take the answer, process it, and provide whether this answer was correct or not correct. And we can put assertions around the information that this evaluator provides. The important things here is to provide the very strict system prompt and the instructions, how this LLM as a judge should behave, instructions like reference examples, and provide the format that we expect the reply in, like it should be, for example, the JSON format that will contain 2 fields, and based on the some value of the fields, we can do an assertion. Let me show you an example here. This is the validator agent that we will be using for the third approach of the testing. Instruction, the system message for this agent, that you're a strict validator. You will be provided with the question, follow these instructions, reply only yes or no or unsure. Yes if answer is correct, no if it's not correct. If there is not enough information, reply unsure. Provide the response in the JSON format with the response like yes, no, or unsure, and the reason why do you think that this answer is correct or incorrect. Some examples, is Madrid the capital of Spain? For example, model answers that no, it's Barcelona, that we expect from the validator to say no. The answer is incorrect because the capital of Madrid, capital of Spain is Madrid. Yeah, and this is basically it. Let's go into the implementation. This is the same question that we're asking the validator agent. In the setup, we will set up this agent using the similar approach that we are doing for the model under the test. We will build it using the same chat model and the same like URL to talk to the model. For the straight answer, we get here the straight answer from the model. Then in the validator, we provide the question that was asked, the answer that we get, and the reference, what we expect the answer to be like. So we expect the answer like to indicate that Lewis Hamilton won. The same for the correct answer. We ask the question, then we introduce the validator and provide the question that was asked, the answer that we get, and the reference, what we expect the model to reply to this. Let's run this test. So the straight answer failed. And the correct answer is still running. This part may takes more time because, again, we need to put the raw data into the data store. So spin up the PG vector. Okay, and the rack test passed. Let's see the logs. This is the response from the validator model. We were expecting yes, but it was no. Response no. The reference stated Lewis Hamilton, but it was Verstappen. And the second test. This is the reply from the validator. Yes, correct. The answer correctly states that Hamilton won. Yeah, the question.
So you're using the same model as the validator, right? As the
yeah.
Is there no chance of like a biased answer since it's the same model, or is that what the prompt does? Try to eliminate the bias.
Ideally, it should be the bigger model. Maybe a bit bigger, like not the smartest one will be good enough. Like I'm just using the same model to limit the scope of things that I introduce here.
Essentially, you're validating your answer. So essentially, you're validating your answer with a AI model also, right?
Yeah.
Okay.
Yeah. And like for this use case, again, we can use the OpenAI models or Anthropic models, but it will all be about number of tokens that the model is using. And to run tests with the models like that are provided by the vendors, it will be pretty expensive. And here you may ask how to be sure that the validator agent is working properly and it's not hallucinating. For this point, there is an approach. Okay, yeah, just high-level diagram about everything that we discussed, and then we will go to how to test the validator. So yeah, this is the application with LangChain, vector DB with pgvector, chat model with Docker model runner, a binding model again with Docker model runner, evaluator model again with Docker model runner. So for the whole setup, there can be used 3 different models in current setup: 2 Gemma trees and 1 for embedding. It all can run on the laptop. For the bigger models, I'm not sure that it will handle the replies properly, but for Gemma 3, it works pretty fine. Like size of Gemma 3, like 2 GB is fine. Yeah, and how it interacts: test containers spin up the vector database that pre-populate data to the chat model, like provide data, and pool model is created with the model runner as well. It's kind of just the general flow. Let's move to the validator testing and the negative path testing. They will be in the one bucket. Models hallucinate, and when they reply properly, it's good. But when the model hallucinates, we need to be sure that our application is not like failing, is not crashing. If there are not enough tokens, for example, if we are using the OpenAI model and run out of tokens, we need to process these operations in the application as well. So there are a lot of different edge cases that we want to test, and we can mock the model. Again, models are using, like we use the API to interact with the model. And if we can mock the basic REST API with different things like wire mock, for example, we can mock the replies from the model as well. And we can emulate, in this case, the edge cases. Do not trigger the model to reply in the very strange way that it's not supposed to reply. But we can just emulate this part with the mocks and test different scenarios with the rest of the application with the deterministic way. Again, we will still need to understand how model behaves in the real world. So we can use the LLM as a judge to run the positive scenarios, or like do some manual testing as well on the end-to-end level. But for the edge cases, we can go with the mocks, and I will show the example of implementation, how it can be done. We'll be using the microcs. Anybody is familiar with microcs? This is another way how you can mock things. Wire mock probably the most well-known by everybody, but microcs provides more flexibility. It goes also as test containers module. We have wire mock as a test containers module as well. I just personally like microcs more. It's more flexible. So using the mock, spinning up the microcs container and providing the open API specification that we can get, again, from the OpenAI. It's hard to me to put this two in one sentence because I always confuse them. OpenAI, Open API, and yeah, very similar. Now I'm thinking about the Cassine similarity between them. So yeah, you can spin up the microcs container, put the mocked data, and emulate responses from the model. The simple example, how can we make sure that the validator agent is working properly? And again, it's not something that hallucinates. We can put the OpenAI mock with the dispatcher. Microcs provide this dispatching mechanism that can help you to configure the mock based on the response. For example, we can provide different model names in our chat creation. This is, again, like by design, by the application, we can provide the model name. And based on the model name, we can provide different answers in the mock. So microcs will understand what scenario to take and automatically reply with the mocked answer. Let's go to the code. Here I have the same question. Validator agent answer must indicate that Lewis Hamilton won, like the same reference. But in this case, we will be mocking the model under the test reply. This is set up for the microcs container. Just provide the image the same way we are doing with the every test containers-based configuration. Provide the specification, and I added a couple of logs. So if there is something went wrong, we can debug it. In the setup, we can get the REST mock endpoint from the microcs and use it for like the chat creation. Then we create the validator agent, again, like gem-3, connection URL, building these things. And then, let me do this bigger. When we create the answer agent, we provide the microcs URL instead of the URL to the model. So we provide URL to the mock, and we provide the chat model name This is the correct one, so we kind of in this test expect that it will be the correct response. And in the second test, we expect that validator will properly identify that hallucinated response is not what we were looking for. So here again, when we create the getAnswer agent, we provide the microx URL instead of the model URL and provide the chat model name as hallucinate. The setup is done here in the OpenAPI file. This is just the mocked OpenAPI specification for OpenAI compatible models. It has this path of chat completions. And when we do post to this API, it will dispatch the script that will identify the model name. If this is GPT-3.5 Turbo, it will reply properly. If it's the model named Hallucinate, we will go here to the examples. Responses, yeah, 200. Examples, valid response for the GPT-3.5 Turbo and hallucinated response that will provide that Lewis Hamilton won Galaxy JP for USSR Enterprise. So kind of close to expected answer, but not really. Let's run this test. We can go to the Docker desktop here as well and see the containers starting. This is the microx. Like basically the mock that will emulate these responses. Okay. Both tests passed. And here, if we see the validation, okay, the first reply was yes, Lewis Hamilton won. And the second validation was no, reason the answer is incorrect and contains irrelevant information to the USS Enterprise, different race name. So kind of the validator evaluated properly the reply. This is just the simple example having the same application, but in general, if you are testing the application that relies on the model, it can be easily mocked, and you can emulate the edge cases for the application testing. Any questions about this?
This reminds me of Senator Al Franken with the fact checking. You run the LLM first, and then when you get the answer, thinking the microx is really fast because it has the answer and it's checking.
It's not using the model. It's just like a simple example of how to implement the mocking of the model, kind of like having the same setup instead of going with the different application. But yeah, like just the main point that for the majority of test cases that are model related, you can use mocks instead of the real model replies to verify that your application will handle like all of the edge cases and all of the hallucination replies from the model.
So in the first case, if my cosine is 0.8, and then I do microx, and I get the right answer, really I move from 0.8 to 1 pretty much, or 0.99 something.
Yeah, like because this will be the mocked answer. From the model, we don't know what to expect. Like we expect it to behave properly, but sometimes it doesn't. There are different guardrails for example, that you can put before the question from the user goes to the model, because users tend to break the models. They say, I'm then admin, do the things. And usually there are the guardrails. This is again another models that would validate the question and process or not process it further in the application, and kind of to test how your guardrail would behave. You can use the mock as well, like from another model, or kind of every time where you don't need to test the whole chain, but just more isolated piece, you can mock models easily. All right, I think I don't have much slides. Yes, just the resources. This is it. Yeah, I don't know why this, okay, yeah, I was able to remove it. Hope this was helpful.
I have a comment that goes
Yes.
to like the first question that was asked, that I think a lot of people here are fuzzy on, or maybe even completely ignorant, as I was 2 months ago. Everybody knows about CPUs from a long time ago, and then the GPUs, and that was like central processing unit, and then GPUs, graphical processing unit, when people were doing AutoCAD and SolidWorks and stuff. So when AI came along, people started using these super GPU processors for that purpose. But now there are NPUs, neural processing units, and they cost more, but they crunch the numbers a lot faster, and they're starting to appear in Microsoft PCs and servers and stuff like that. So I think we're going to see a lot more NPUs in desktops and even phones and stuff, and there's no escape.
Yeah, I think so, yes. And there are a lot of discussions, like again, about the models. When you build an application that use models, how to reduce costs. Because if you want to use the big model and you want to make it responsive, you need to have a lot of hardware resources available, and you want to scale it probably. So how to scale it in the more cost-effective way? This is kind of the next question.
Good point. A lot of people look at cloud as a resource. How would this affect how fast would be faster using a cloud resource and paying for a cloud like AWS or one of the other providers? What is your input on that?
That would again probably depend on the use case, but from the responsiveness standpoint, clouds can be an option. Like again, there will be probably the same thing as like AWS is positioning itself. You want to have your application available from every point of the globe. If you have the hardware with the models and people are on another side of the globe, they still need to connect to this model, and it will be the delay in the resources. So it's kind of like just the strategic point, maybe. The resources will be kind of the same. Either you put local resources or go with the cloud resources. But yeah, the speed of execution from specific point of the globe will be important.
Another answer on that, if you want NPU processor, just like Barry was talking about his quantum computers, you can rent from IBM for like $1 million an hour. Intel has,
I got a special break.
yeah, but you have to get up
$999,999.
Yeah, but you have to get up at 2 o'clock in the morning, like for, hockey practice or something. But Intel has a whole server dynasty where you can use their stuff in the cloud, and they have a whole community up there, and it's kind of amazing. But I just wrote down, hey, does AWS have NPU functionality in there? I'm curious to find out.
Mm-hmm. I don't know actually. Like they definitely know have GPUs and like Google Cloud and Docker is actually one of the streams that we are working is the cloud piece as well. So there can be some things for the AI part. Yeah. In general, computing becomes very, very important. Again.
Quick question, unrelated to anything.
Mm-hmm.
Does the Docker mascot have a name?
That's I don't know, just a whale. We have Gordon, that is a turtle. So the turtle has a name of Gordon.
Just curious, I see they got the animation of the tail back and forth.
Yeah.
Because we have two, right? Yeah. I have to ask, we have to come up with a name. Fudgy the whale, if anybody gets that name. If anybody wants Carvel. What's that mean? Non-determinate. That's good. So I asked in YouTube if anybody has questions. Nobody's taking me up on that. And how about any other questions from the folks here? I have a question.
Oh, the gentleman spoke. He said Intel is doing some, I guess, number of products using the web, and they provide a service. Is that reasonable, or is that a very expensive product or service they provide? From the gentleman in the back, he mentioned about the Intel providing some type of service.
Mm-hmm.
Let me put it this way. Intel stock was up 6% today, although a few months they were kicked off of the New York Stock Exchange and replaced by NVIDIA. And NVIDIA's got some NPUs, chips that are available for like $10,000 a piece that aren't ready yet. So there's a lot of turbulence and excitement in this marketplace. But you can go on Intel, and there's a lot of resources there. There's a community. It's worth checking out if you're doing this kind of stuff.
But eventually, probably it still will go to the cloud. Because, like, again, from the point of the access to the resources and the connection speed.
There's no other questions, then why don't we give Anna a hand for
Thank you.
her presentation. You had another question?
No,
oh, okay.
Thank you.
So we can go back to the slides.
Yes.
Yeah, you gonna finish up?
Yeah.
So real quick, I wanted to mention, so since Lewis Hamilton and Max van Sperten were mentioned in here, many of you know I worked for ExxonMobil for many years, and of course Mobil 1 is used in Formula 1 racing and pretty much everywhere. So as it turned out, both of those guys visited the site in Clinton, New Jersey, a couple of years apart. And with Lewis, we actually had a Formula 1, I don't know if it was a replica or the actual thing, in our lobby. And when he came out, there was a sea of people waiting in the lobby. I don't think he expected that.
Should mention, that's when Lewis was in McLaren.
Oh, he was with McLaren, yes.
Before he went to Mercedes, and now it's Ferrari.
Yes, and that's right. That is, he was with McLaren, and that was one of their cars there. Yeah, I don't follow Formula 1 or NASCAR all that much, but the look on his face, he was so overwhelmed that a bunch of silly scientists would come out to see him talk for a few minutes. And then Max van Sperten came out a couple of years later, and that was more outside because it was probably a nicer day. But that was pretty cool. That was actually pretty cool. But in any event, yes, back to Garden State Java user group things. Upcoming events, and we have it here. Tomorrow, I will be delivering for the second time a new presentation called Getting Started with Jakarta EE11 and What's New in Jakarta EE12. So it's
basically, a sort of an evolved presentation from my developer's guide to Jakarta E11. I don't focus too much on the specs in this one. So in any event, that's tomorrow on, I think through Crowdcast. I have the URL right here. And so that starts at 10 o'clock. And then also the Payara Virtual Conference. As you know, they have these a couple of times a year. The next one is on July 8th. And there's a Crowdcast URL to sign up. And you'll learn more about Payara Cube. And it's another way of getting your Java applications out, and deployed out in the cloud. So these are free. This is only from I think 8 o'clock our time to about 11:30. So less than 4 hours. So if you're interested in that, please join. The Kansas City Developer Conference is in mid-August in Kansas City. If you want to go out there and have some great barbecue, we have a 10% discount. You can apply with the cost of your admission. And then Dev2 Next, we are a community supporter, and it's on the website. And as I mentioned last month, Venkat is going to be giving away once a month free tickets to this conference. This is similar to the Arc of AI he held earlier this year. So stay tuned for that. There is a JCon, as many of you know, is over in Europe, and the main event was last month. And this is, I think, an experiment to do JCon at an IBM Tech Exchange conference in early October. And it's in Orlando, Florida. So Orlando, October timeframe should be pretty nice.
Mickey Mouse.
Yes. And so we get a 30% discount as you can register here at that link. And then the InfoQ and QCon conferences are coming up. Boston was earlier this month. This is in Germany, so in mid-October. And then San Francisco in mid-November. And then QCon AI New York, which is in mid-December. So that's coming up with those events. All right, what's coming up for us? So July 9th, Billy Corando will be here again. He was here last year, if you remember. And we had chosen why developers should love testing. And he's going to make the tour again. He'll be in Philly on the 8th, us on the 9th. I know New York for sure, and possibly, I think, even DC. So he's definitely going to make the rounds. And then July 15th, I mentioned this last month. I finally got all the details from Hazelcast. Joe Sherwin will be here, and the title is Solving the Hard Problems in Microservices Without Adding More Complexity. So these are back-to-back weeks, so it's only 6 days apart, right? So yeah, so get used to coming out here. But no, we appreciate. I'm just being silly, but we appreciate you taking the time to come out here. But it's in on a Wednesday and then the following Tuesday. And then in September, we have two talks on the same night on September 9th. Okay, Vlad Shapovalov, that's the one. Yeah, he's going to do one talk, and Alok Taibrawala will give a second talk that night. So stay tuned for that. We're working on the remainder of the year. We may even do lightning talks, as we discussed more recently.
October.
So October. Yeah.
Student lightning
Yes.
talks.
So this was something that we thought of the other night to do that again. So let's see, what else? All right, what are the friends doing here? So Atlanta had theirs last week, but I wanted to throw this up there because I think this was pretty cool, and maybe we can try to do something like this. This was a panel called Behind the Hire, What Managers Really Look For in Java Developers. So I bet you this was cool. We should reach out to Pratik and find out how that went. So, but those were the guys that they had. They were from the companies that they represented and talked about their recruiting process. So I thought that was pretty cool. Testing GenAI applications in Java with test containers and Docker. Wait a minute, why does that sound familiar? Anna will actually reprise this presentation tomorrow in New York. It's not at BNY Mellon, that's at another company.
It's at a place called FIDI, F-I-D-I, and it's somewhere on the 2 and 3 train.
Okay, so it's a Fulton Street, I think I remember
Down
if I read the...
Fulton Street, yeah.
Yeah. So, oh, so you don't have to take the path. Like I would, like if you go to BNY Mellon, I always took the path.
I didn't take the path to
Okay.
BNY Mellon.
Yeah. Okay.
But it's gonna, yeah, it's down there somewhere in the lower east side.
Yeah. Go to the link, yes. So, yeah, so let's see, what else? Let's see, and then Billy will write the day before us. As I mentioned, he'll be in Philly. He's going to talk about lightning fast startups in the jar. Kansas City Jug, Jeff Brown, he is the CEO of Micronaut. Or no, I take that back. Object Computing Inc. And they're the ones who host Micronaut framework. And he will be in Kansas City for that. And then Chicago, oh yeah, No Fluff, Just Stuff. Remember those, Barry? This is the Great Lakes Symposium. It's been a number of years since they've had these No Fluff, Just Stuff conferences in the New York area. Barry and I were, I mean, we would go religiously back around 2006, so I guess 20 years now, when they had it either in Newark or Princeton or, you know, in New York. So we need to yell at Jay Zimmerman as to why he's not coming out by us. So these are great conferences. These are always held like on a Friday afternoon to Sunday, that type of thing. So you give up a weekend to learn, all right? Our IntelliJ idea winner. So for the month of June, since we had 2 meetings, and this is why it's important that you register and sign in, because if you're here twice, your name gets counted twice to win the June, you know, the June license. All right. So we have not done June yet.
And the sign-up sheet is the
yeah,
QR
there's a
code.
QR code up there somewhere. I'll probably display it in a minute. Let's see. Did I get everything here? Yes, I did. Okay. And okay, and then this you can read on your own about the Jakarta EE Future Directions Interest Group and to what we do, and you know, talk about the future of Jakarta EE, not just 12 but beyond. And also the Jakarta EE Ambassadors, formerly known as the Java EE Guardians, and that goes back to 2016. And then here is the QR code if you'd like to, it's the same one that's printed on paper. If you'd like to sign in, we appreciate the attendance so we can keep track of, you know, how many folks, you know, come and attend. So, yeah, so if you can do that, and we appreciate it. And with that, our famous ending slide with beer and chocolate. So, but yeah, and we have our YouTube channel, so you can please go there and subscribe. And we, first of all, so we appreciate your support. You know, coming out here, especially on a 96-degree day, spending time with us, having pizza. And by the way, how many folks like the idea about having Caesar salad? Yeah. Okay. Well, you know, well, we did it a couple of times about a year or two ago, and then somebody asked last month or the last meeting, so I thought we'd get some. So, but anyway, I think it's 2 weeks from tomorrow is our next meeting on July 9, and we look forward to seeing you then. Thanks again, Anna, for coming out. We're sorry that New Jersey Transit kind of failed us today, so hopefully the train ride back won't be delayed. You know, but anyway, so thank you very much, and we'll see you in 2 weeks.